So here we have the synaptic cleft, which is a small gap where the neuron or the presynaptic terminal is going to meet with the muscle. Within these border end plates here, we have these synaptic vesicles filled with neurotransmitters called acetylcholine. Acetylcholine is going to be key in order for muscle contraction to happen. Once you get a signal from the central nervous system, it will travel through the dendrite all the way down to the presynaptic terminal. The signal will then turn these vesicles inside out, which would release acetylcholine. Acetylcholine is then going to bind to these receptors here along the membrane and will allow sodium to go through the cell. Depolarization occurs once sodium goes through the cell, which will cause the cell to be more negative, and as a result will form an action potential. An action potential acts as electricity, which will cause something to happen within the cell. Action potential is going to travel all the way down the T-tubule here, which will then activate the sarcoplasmic reticulum, known as the SR. SR houses calcium, which will then be released and travel down to the myofilaments. Here we have actin and myosin. Calcium is then going to bind to troponin, which would then cause a shift in the tropomyosin. This process is then going to expose active sites, and as a result, the myosin heads will pop up and bind to actin.